Linear and nonlinear functions. First, we need to identify the definition of each of those. And if you recall, a linear function is an equation where you create a line, a single line. It doesn't have to go straight up and down or straight from right to left. It can be a diagonal, but a linear function is when you create a function that creates a line. Now, a non-linear function is a function that do not have constant rate of change. Therefore, the graph will not create a straight line. Now, here's some examples of some nonlinear graphs. In the first one, as you can see, this would be a graph that creates a curve, and because of that curve, you can automatically see that it is nonlinear, because again, linear creates a straight line. Looking at the top right one, it creates what we call a parabola, which is a U shape, and again, there's a curve, therefore it's nonlinear. The next one, again, there's a curve, so it's nonlinear. The last one here creates a V. Well, again, because of that V, it makes it nonlinear, because a linear function is going to be a straight line. There's not going to be any bends, bows, or curves in it. Now, looking at some examples of some linear functions. Now, if you look at what I highlighted here, I highlighted in the word linear, I highlighted the word line, because a linear function creates a line. Now, if you look at the top left, this is just a basic function that's got a positive slope, and it's constant. So the rate of change is constant. It's the exact same change the whole way through the line. And that's the case with each of these examples. Now, if we want to identify functions using tables, if we look at the first example on the left, our x and y values are given to us. X is 2, 4, 6, 8. Y's are 1, 2, 3, 4. If we look at what changes from one to the next, to get from 2 to 4, we have to add 2. From 4 to 6, add 2. From 6 to 8, add 2. So we're seeing that it's a constant change of plus 2 on each of those. Now on our y side, it's from 1 to 2 is plus 1, 2 to 3 is plus 1, 3 to 4 is plus 1. So our x change is always the same, and our y change is all the same. So we can identify this as a linear function. Now if we look at the second example on the right-hand side, from 1 to 2, we add 1. From 2 to 3, we add 1. From 3 to 4, we add 1. So x's, the rate of change is all the same. But if we look at the y's, to get from 1 to 4, we add 3. From 4 to 9, we add 5. And from 9 to 16, we add 7. So our y's are all different. That creates a nonlinear function. Now, if we're identifying functions using equations, there are some rules that we can use. Every linear function can be written in slope-intercept form, which, if you remember, is y equals mx plus b. So if it can be written in y equals mx plus b form, then it is linear. So if you look at this first example, y equals 3x plus 1, that's written as y equals mx plus b. The second one, however, is 2x plus y equals 3. Can we write that in slope-intercept form? Well, yes. We would just get the x on the other side, and we would be left with y equals negative 2x plus 3, showing us that is a linear function. The second thing is, if there is a variable that is an exponent, it is not a linear function. For example, y equals 2 to the x power. See how the x is an exponent, therefore it creates a nonlinear function. The other example, x equals 3 to the y power. Well, if you have it to that power of an exponent that equals a variable, then it's going to create a nonlinear function. So both of those are nonlinear. Okay, the third thing is, if the exponent on a single variable, such as x, is negative or greater than 1, it is not linear. For example, y equals x squared. That is nonlinear. How the x has an exponent, that creates the nonlinear function. Y squared equals x, also creates a nonlinear function because, again, that y is an exponent, has an exponent of 2, and because of that it creates the nonlinear function. Another example is y equals x to the negative fourth power, because as we know, what happens when we have y equals x to the negative fourth power? That negative 4 doesn't change the value of the x. Instead, it flips it and creates a fraction where we have an x on the bottom to a power. It doesn't matter if that was to a negative 1 power, to a negative 10 power, it's going to tell us it's a nonlinear function.